Okay, welcome back everybody. I'm Matt and this is Camping and Coding. We're going to continue our Leetcode daily problem series here with Leetcode 1331, rank transform of an array, which is the daily problem for July 12th, 2026. Okay, so given an array of integers, replace each element with its rank, where the rank represents how large the element is with respect to the rest of the array. So the rank has the following rules. It's an integer starting from 1. The larger element, the larger the rank. If two elements are equal, their rank must be the same, and rank should be as small as possible. Okay, for example, we have an array with 40, 10, 20, and 30. 40 is the largest, so it has rank 4. 10 is the smallest, so it has rank 1. 20 is the second smallest, so it has rank 2. And 30 is the third smallest with rank 3. Okay, so we are going to do this in Python. I am going to implement this in two different ways. The first way is going to be more mechanical, and it will show you hopefully a little more clearly or more obviously what's going on. And then I'm going to redo it in a way that will show you kind of a functional programming Pythonic way to do this. All right, so let's get started. All right, before we begin, please do make sure to like and subscribe. It really helps me out and motivates me to continue making these videos. All right, so first, the more rote mechanical way of doing this. All right, so we know that we're going to return an array. Well, first of all, let's set up our class for the solution and define our function. As with all class functions, self has to be the first argument, and we're going to return a list of ints. So let's import typing, and from typing import list. That lets us do this typing in the function signature without breaking anything. Okay, so we know we need to return a list of ints, so let's just call that our result. For now, we'll make that empty. And then we will return result. Just set up our boilerplate here. Now, we know from the problem description that we need to have a rank for every single element in the original array. So that means our output list is going to be the same length as the input list. We also know that 1 is the smallest, so we're going to initialize everything to 0 because that's smaller than the smallest. So in Python, you can initialize a list by multiplying whatever initial value you want by the length that you want that list to be. Okay, next, we only care about unique values. So that is because if two of the elements are equal, their rank must be the same. So we don't want to have two different ranks for 100 here in example 2. We want to have just one rank, which is 1, because it's the only value, or rather because it's the lowest value. So what we are going to do here is use a data structure that can handle unique values. We don't necessarily care about how these are sorted or ordered at this moment. And so for this use case, we are going to use a set. Unique is a set, and in Python, you can just directly pass the thing you want to convert into a set, which in this case is our input array. I just said we don't care about the order or the sorting. That's actually not true. We inherently care about that because we want to know the rank of each element. So it's easy in Python to make this happen, much easier than it is in, say, C++. So we can just directly sort our list, which is very nice. That will give us a sorted set of values that are the unique values in array. Okay, so now we need to know the ranks of each of these values. And so we need to know that value 40 ranks to, or maps to rank 4, value 10 maps to rank 1, Since I'm saying it maps to something, that's kind of a giveaway. The data structure we want here is a dictionary. In C++, that would be a map. So we'll call that ranks, and we'll just initialize an empty dictionary. Okay, now we know our lowest rank is going to be 1, so we can just start with 1 for our rank. Okay, so now it's as simple as just iterating over all of the values in our unique sorted set and pulling out and mapping the value to its rank. So for value in our unique sorted set, ranks at that value is equal to whatever rank currently is. We know that this is going to be 1 for the first value because we sorted the unique set of values. And then we'll just increment rank. Okay, so that's good. Now we have a dictionary of ranks, which will look something like this. It will be 40 maps to 4, 30, let's do this in the right order, 10 maps to 1, 20 maps to 2, 30 maps to 3, and 40 maps to 4. Or in our other example, let's use, actually let's stop there. Okay, so that's what our ranks look like. Now we need to simply put the rank in the correct place of the original value in array. So how are we going to do that? Well, we can simply iterate over the original array, and since we have a dictionary, we can do O of 1 lookup for the value at each index in the array. So we can say for I in range, the length of the array, range is exclusive of the closing value. Then we can say I want result at that index to be equal to the rank of that value, and this is where the O of 1 lookup is very useful. And then we'll just return the result. Okay, so let's run this test suite and see what happens. Okay, everything passes as expected. So this is a correct solution. It's just not a very elegant or concise solution. So let's try to make that a little better. So I'm going to show you a more Pythonic way to do this. And it's really beneficial. It's a little confusing at first, but I think you'll get the hang of it. And it really leverages all of the good parts of Python that this original solution does not. So let's start by recalling that we need to have a collection of items that is sorted in ascending order, but it's only the unique values from our input array. Okay, so we decided that was a set that gives us the unique values and that we needed to use the sorted method to make that happen. Okay, so we can do that all in one line. We can say sorted unique is equal to sorted set of array. So this looks a lot like composing functions in math, and that's because it is literally composing functions. It's the set constructor and the sorted function. Okay, so now sorted unique is a list of unique values in ascending order from our original input array. That's nice. Okay, so now for our ranks, we're going to do the same thing that these 5 lines do, but we're going to bundle it all into one line. And we're going to do that using 2 different tools. One is the Python dict constructor, and the other is zip. Okay, so the dict constructor just creates a dictionary from whatever is passed as input to that constructor. That's pretty straightforward. Importantly, it needs to have 2 iterables as, or rather, it needs to have an iterable where it has a key and a value pair passed to it. And that is exactly what zip gives us. So zip takes 2 iterables and it returns that as one zip blob that has all of those things married up together. So to make this a little more concrete, we will say ranks is going to be equal to our dictionary. So that's just our constructor. And then we're going to zip the first iterable. And so this will represent the key. So let's do this. Dict will be, it'll take the key and then it'll take the value, right? So that makes sense because dictionaries look like this: key, value, and on. Okay, so zip takes two iterables. Well, we know what one of them is. We know that it's the value, and we know that that needs to be the key because we need constant time lookup here for this placement in our results array. So we'll have our sorted unique, if I could spell. That will be our first iterable. That's just the entire list that we created of the unique values. The second one is a little trickier. What do we want here? If you wanted to zip up the location of each value in sorted unique with the values associated with that index, you could do range length sorted unique. Okay, so importantly, these iterables need to be the same size so that they can map one-to-one. So this would give us something like the resulting dictionary would look like 10, 0, 21, 32, 43. Because that's the index in sorted unique of each of those values. 10 is the first value because it's in ascending order, right? That makes sense. But that's not what we want. We want our rank to start at 1. So this is a classic off by 1 error. So the way that we fix this is we just simply start our range from 1. And since range is exclusive, we need to extend all the way up to and including length sorted unique. Okay, so that will give us what we actually want, which is this. And so on. Okay, so that's good. That's just a simple way of basically cutting out all of this boilerplate, which is very nice. Let's clean this up a little bit so we can really see the benefit that we're getting here. Okay, and now the rest of it is the same. We just iterate over every value in the array and assign something. Do we have a results list? No, we do not. Do we care about that? No, we do not. We can update array in place. So we're going to say for I in range, the length of the input array. Uh-oh. I think I have a typo here. I'll find it later. The length of the input array, the array at that index is going to be equal to the rank of that value in ranks. And then we can just return array. Okay, let's see if I didn't screw this up. Great. I did not screw this up. That's fantastic. Okay, so in addition to being tidier and more traditionally Pythonic here, which is good, interviewers like to see that, it shows you have a deep understanding of Python, we're also saving a little bit in terms of memory. And that makes sense, right? Because we're not initializing this results array that's the same size as our input array. So we're not duplicating that, that size. So that's good. So the complexity of both of these solutions is O of n, is O of n log n, and that's because of this annoying sorted operation that we have here. The Python sorted method returns is O of n log n. But other than that, so that dominates our complexity, and the rest of it is O of n. We're just iterating over everything once, or more than once in both cases, but never nested. So it is still just big O of n for those operations. Yeah, so I hope this was helpful. If it was, please like and subscribe. And I'll come back next time for more explanations. Thanks.